Hello, Maurieo! Maurieo reviews Engineering Math Quiz 1. Hello! In this video I'm going to take a look at Maths Quiz 1 and go through each of the problems as they appear on the sheet. There are a number of issues that some students need to address, and I'll get into those as we do each question. So let's first of all, let's have a look at Smooth Draw, and let's get that up on the large screen. So here we are. This is the first question here, and we have to simplify this one. So first of all, we've got to get the pen working properly. Okay, so we just like so and like so. Sometimes it can be a little bit problematical. Okay, so here we go. Now, first thing is that when we have a situation like this where we're cubing indices, so indices, when we're dealing with indices, they're a bit different. So in a situation where we've got powers of indices, that there is going to be equal to x to the power of 4 times 3, because we're powering the indices. Okay, so 4 times 3, and similarly it's going to be over here x to the power of 2 times 3. Now you might think, well, how do we remember that? Well, perhaps you should have a look at the formula sheet that's handed out and is available in each exam, because usually they have little things of these, the indices rules, for the rules for indices. So you perhaps need to practice looking for those rules, seeing where they are and seeing how they use them. Now they might be in the form of something like a to the n brackets to the power of m. I haven't got the formula sheet with me, so I'm just going off the top of my head here, equals a to the power of n times m. So in the case of this one here, then it's just a matter of filling in the, so you can see n is 4, m is 3, n times n. So this works out there. So there we get x to the power of 4 times 3 is 12, and on the bottom x to the power of 2 times 3 is 6. Now that just means x to the power of 12 divided by x to the power of 6. So if we're multiplying indices, like x to the power of, we add them, and if we're dividing, we subtract. So that just equals x to the power of 12 minus 6. So that's x to the power of 12 divided by x to the power of 6, and that equals x to the power of 6. So it's just a matter of knowing your indices and the rules there. Nice simple little problem there. Okay, so now let's look at the second one, factorize. Okay, so factorize, that means we're going to try and find common factors, and rather than expand, we're going to put them into brackets. Now if we look here at the 6, we look here at, I don't know why that's starting to move around like that. We'll just have to stabilize it there like that. That seems to work, seems to do it. So if we look there at the 6, we can see that there is going to be 2 times 3. Okay, so I'm going to put that in there. That 6 is 2 times 3. So I'm just putting that there, and I'm looking here at 9, and I'm thinking, well, that's 3 times 3. And I'm looking here at 12, and that's 4 times 3. Like so. So what I can do is I'm going to put a bracket down here. I'm going to make it a pretty big bracket. And I can see there that of the numbers, 3 is what we call a common factor. 3, 3, 3. So I'm going to put a 3 there. Now I'm going to have a look at x's. There's an x there. There's an x there. But there's no x here. So x can't be a common factor to all 3 of those. Y, there's a y there, a y there, and a y there. Now y can be a common factor then because it's in all 3. But the highest power of the y is 2. And the lowest is 1. So it's going to be the lowest. So it's going to be the y. We can put a y in there because there's one y common to all of those. Now let's look at the z. We've got a z there, no z there, and z there. So 3y is a common factor. Now we say the 3, so that's going to be 2. And we take out the y, x, z. 2xz plus, now we've got 3 times 3, so we can take out just 1 3 plus 3. X is not common to anything. We can take out one of the y's, not both of them. And then we can come here and we can take out the 3, which will leave 4, and we can take out the y, and that'll leave z. And there we are. There's our answer. Factorising that, it equals 3y brackets 2xz plus 3xy plus 4z. And I'll just write that nice and tidily, well, as tidy as I can. So that's 3y brackets 2xz plus 3xy plus 4z. Okay. And that's the answer. So when you're doing these quizzes, it's a good idea to make sure it's very clear where your answer is. Some people wrote some bits of stuff underneath and off to the sides and things like that, but just clearly indicate where your answer is. Maybe put a line under it or something like that. Okay, so that's the first 2 done with relative ease. So now I'm going to just have a look at the second lot of questions, and we'll just just number 3. So it's expand and simplify. So it's always good when you're doing these problems to have a plan. So what would my plan be here? Well, I'm going to multiply 4x squared by y, and then I'm going to multiply 4x squared by z, and then I'm going to multiply 4x squared by w. Okay, now then I'm going to multiply, this is a bracket here and this is after it, but it's the same as if it was in front. So I'm going to multiply that by that, and that'll create a term, and then also in the y squared here. A little bit wobbly there. I might just undo that and try and go a bit better. And so I'm going to put all those terms together, and then if there's any like terms, I'll collect those. So I'm going to get 4x squared y plus 4x squared z plus 4x squared w plus w y squared minus w z, which is in here. All right, and I think that's pretty much it. I don't think there's anything further that you can do with that. So it is a question of just knowing when to stop sometimes. So that there's our answer there. Pretty easy one to identify. And now finally we're going to go to question 4. And this is a simplify one, and it's with powers and indices and whatever. Bit difficult to know where to start with this one. A lot of students didn't quite go far enough with it. But what I'm going to do is just look. So first of all, we've got this fourth root here, and we've got 16. Now what I did is I looked at 16. Now 16 is a pretty interesting number, but if we go 2 times 2 is 4, times 2 is 8, and times 2 equals 16. Okay, now I knew that about 16, so that is actually 2 to the power of 4 equals 16. Okay, and that's 16 in there, and we've got a sort of fourth root here. Now that the fourth root of 2 to the power of 4, which is 16, equals 2. So that's sort of handy to know. Very handy to know. Now, what I'm going to do is I thought I'd just stay with the power, the fourth root thing right to the end, or I could just write it as a quarter. So I'm just going to go a bracket like that, and then I'm going to go x cubed y to the 6th over, I might just write that as 2 to the power of 4 if I wanted, just to make it interesting. 2 to the power of 4. And then this is xy all cubed. I'm going to expand that out. So that's x cubed y cubed. Okay, so that's, and then that will be to the power of a quarter, the fourth root. Okay, so now it's all in indices, but straight away I think we can see here that that x cubed, we've got an x cubed on the bottom, which we could cross out there. We've got an x cubed there, and we've got a y cubed here on the bottom, and a y to the 6th up the top. So we could just cross out that and make it a 3. Okay, just like so. So writing that, right, that's what it equals there. So writing that out in full, now that we've done all the things, we've got y cubed over 2 to the power of 4. Okay, all in a big bracket to a quarter. Now we know that from our indices that we just multiply. So we get y to the power of 3/4 over 2 to the power of 4 to 1/4, which is 2. So we get y to the 3/4. I'll try and make that a bit bigger. To the 3/4. No. So that's y to the 3/4 over 2. Or we could write it, and many students did, a half, 1 on 2, y to the 3/4. Like that. And there you are. There's your answer. Okay. So, yes, that brings us to the end of the quiz. And as you will know, it all looks very simple when someone explains it to you, just as I have done. Well, I hope it does. The question is, how to deal with it in the exam situation. Now, there's a saying that goes around that says that the amateur practices something until they get it right. The professional, and I hope that you are all intending to become professional engineers, the professional keeps practicing something until they never get it wrong. So the key to this is to find lots of examples. So get lots of examples, give them a go, try, make sure you can do it. And it's only from the experience that you get. The experience that you get from doing lots of examples and experiencing all of the different nuances and ways and differences and things like that, that you become proficient at this. And that is the important thing, to get yourself a lot of experience. However, I would say that after going through this, you should be able to write out these questions, these very questions here. Just write out these very questions here on a blank piece of paper and answer them, correctly. And until you can do that, and to yourself, and until you can do that, I don't think that you can really, you should move on from there, because if you can't do that, what hope do you have of confidently solving a new question? So I'll leave that with you there. This is the answers to quiz 1. We'll see you again next week, hopefully, with the answers to quiz 2. Cheers. See you.